question for you, because everybody talks about this boosting, especially extreme gradient boosting, because that seems to be the highest of the orders. So what are the hyperparameters? As it is the model inherently is kind of perceived to be super powerful. So what is it that the hyperparameters do, and what are the hyperparameters for extreme gradient boosting? Can you elaborate on that a little bit?
Sure, absolutely. So even before I go to extreme gradient boosting, let me explain about the other boosting techniques. And even before we proceed further, let me tell you that within boosting, predominantly we have AdaBoost, then we have gradient boosting, and then we have extreme gradient boosting. These are the three things that we have. Okay. When it comes to AdaBoost, we have all these hyperparameters. The important thing that people have to remember from interview standpoint is that people ask, what is a base estimator? Base estimator is decision tree. It's not just decision tree, but decision tree with maximum depth equal to 1. Okay. And the next question which people usually ask is about learning rate. And there is also gradient boosting. Within gradient boosting, we have the loss. Now, when it comes to gradient boosting works based on optimization. And the objective here is to minimize the loss. And then you also have learning rate, the speed at which you want to minimize the loss. Of course, that does not mean that you're going to give a very high value so that quickly the loss is minimized. If you increase the learning rate, there are some other disadvantages. But then the learning rate, the loss, and then the criterion based on which you evaluate your model, then minimum samples at split, minimum samples at leaf, maximum depth. All these are a few common things across various ensemble techniques. But these are a few things that one has to remember. And having said that, complexity parameter is something wherein people will be questioned, and on tolerance level. These are the two things. And then people will also ask questions around what is the difference between tolerance, complexity parameter, and cost complexity parameter, and the loss function. So one should be aware of the differences between all these, right? Having said that, XGBoost, the question was around XGBoost. There are more number of hyperparameters which exist. A few are listed down here. XGBoost is becoming extremely famous because of its parallel processing capabilities. And even if you have a very huge data set, it is going to execute and accomplish the training faster. And none of the other boosting techniques have the parallel processing capabilities except for XGBoost. Okay, and here there are a few hyperparameters such as number of threads. What did I say? I told that XGBoost is extremely famous because of its parallel processing capabilities. When you give number of threads, then obviously it will make use of your cores. You might have a dual core, you might have a quad core, you might have octa core, so on and so forth. Then you also have eta value, learning rate, maximum depth, maximum leaf nodes. Then we have gamma, subsample, column sample by tree, so on and so forth. I can show you a few more, just a moment while I show you those as well. Yeah. And this doesn't mark the end. Okay, whatever I'm going to show now is also not the end of the story. You have a few more hyperparameters. Okay, and the explanations pertaining to each of those is very neatly explained here in the table. Once again, if you ask me, you will have to focus upon gamma, the subsample, and you have a bunch of things here. Alpha value, lambda value, right, which also act as regularization techniques, right, which will help your model fit right. It will do a proper trade-off between bias and variance. And if you refer to this specific column here, it will help you understand on whether the relevant hyperparameters will avoid overfitting or not. Would it increase the overfitting, preventing the overfitting, or will it decrease? And then the range, not just the default values, but what could be the appropriate range for those relevant hyperparameters is also clearly explained here. So, yep, those are a few things that I would like to bring to your attention. Over to you, Nitin. Hello.
Thank